Alright, so now let's have a look at unit cost depreciation when we're using the general formula. So before we get into just the general formula, I want to have a little bit of a pre-thought before we get started. So if I'm trying to figure out, well, how much am I going to lose over the total life of my product? Okay, I want to use this concept that, well, the total that I take off is going to be the number of uses times the cost per use. So if I drive 2,000 kilometers, I want to multiply the number of kilometers by the cost per use. Now, if that's not actually given to us, so we're not told how much each use costs, what the unit cost is, we can figure it out in this method. So if I want to figure out how much it costs for one use or one block of uses, well, that's going to be the initial minus the scrap value. So that's going to give us the total amount lost divided by uses, and that's going to give us the loss per use. Okay, so we may need to come back to this. So getting into what our actual formula looks like, again, this should look fairly familiar. Well, the current value is whatever we started with minus the depreciation. So essentially it's taking that initial concept and putting it in there. N is the number of uses, D now is the cost per use. Okay, so with these formulas it is important to remember what each of the symbols stands for. So this minus ND here, that's telling us how much total we're losing. Okay, so that's going to be the number of uses times the cost per use. Sorry. So let's have a look at two examples, one with a photocopier and one with a car. So we'll start with the photocopier. So we buy this brand shiny new photocopier. It's $8,900. And it depreciates at $1 per ream. A ream is 500 sheets of paper. Okay? Now, in the first 2 years, this photocopier makes 1,500,000 copies. Okay? So it's quite a lot of copies. I want to figure out, well, what is it actually going to be worth after 2 years of owning this photocopier? So let's figure out what it's worth after 2 years. So I like to, again, write out my symbols. So Vn I've started with, well, that's what I'm looking for. I'm looking for the future value, so I don't know that guy. The initial, that was the 8,900. Now, we just have to be a little bit careful here. So N is the number of uses. Okay? So I've kind of got two ways to approach this, because my uses is given in copies, so single sheets of paper, whereas my rate is given per ream. So I'm going to choose to leave this as the number of copies, and I'll express my rate as a number per copy. So my number is 1.5 million. So because this is in sheets, this rate needs to be in terms of sheets as well. So it loses $1 per 500 sheets. So again, my options are either to already have divided this by 500 and give it in terms of reams. Okay, so I could say this is 3,000 reams, or I can give my D as 1 over 500. It really doesn't make any difference. Okay, just which is going to make more sense to you. So whether I convert this to reams straight away, so that this can be in terms of reams. So my Vn, well, that's my initial value minus the uses, so N, got all my zeros there, times my rate, my number per use. So I'm charged $1 per 500 sheets. So looking at this, okay, if you want, you can cancel by hand. 3. Okay, so you'll end up with 3,000. If you're unsure, go to the CAS, putting in 5. Okay, to get 3,000. Either way is fine. So I get that I lose $3,000. So it's worth $5,900 still at the end of those 2 years. Okay. So again, really important that you're aware of units, because this was per ream. I had to convert my rate not to just $1, but $1 per 500 to make those the same unit. That's really important. All right, now let's look at a car. So we buy a car for $20,000, and it reaches its scrap value once it gets to $1,000, but that's also given as driving 237,500 kilometers. Okay, so I'm going to break this question into 2 parts here. First of all, well, what's the unit cost of depreciation per kilometer? So exactly when I drive 1 kilometer, how much value does my car lose? And then furthermore, using that rate, how far can I drive before it reaches $14,000? So maybe at that point you want to sell, but that's what we're going to be looking for. So with the first part of this question, what is the unit cost of depreciation per kilometer? We can kind of think about that question in 2 ways, depending on whether we want to think about it, just kind of reason through it. Well, how much do I lose? Divide that by the number of kilometers, or using the formula. So let's first think about, well, what's the total lost? So what's my total depreciation over this time? So in the time it takes to go from 20,000 to 1,000, which is when it drives this amount of kilometers, it loses $19,000. So the total lost, really important to label all of your calculations so it's clear what you're doing. So my total lost is $19,000. Okay. Now if I want to think about that per kilometer, that's $19,000 divided by, so again, dollars, the number of kilometers. So my unit cost, if I actually do that division, getting 19,000, extra 0 there, divided by 273,500, I get 0.08 dollars. Okay. So you can either think of that as $0.08, or you can think about that as 8 cents per kilometer. So that's kind of the way to reason through it. Otherwise, okay, think just blindly plugging into the formula. So here we're going to be solving for D. So Vn, so that's kind of the amount, the value at the end, so that's going to be the 1,000. V naught, that's going to be what it started at, so that's the 20,000. The N, that's the number of uses, so that's 237.5. And D is what we're looking for here. So if I was to fill in my formula, I would get 1,000 is equal to 20,000 minus 237,500D. I've forgotten a 0. So if I was to now go through and solve this, if I'm content to do this, I can just use solve, comma D on the CAS. If not, subtracting the 20,000 over, you would get negative 19,000 is equal to negative 237.5 dividing both sides. So giving you a few alternative ways to be thinking about this. So whichever way you swing it, you end up that D is 0.08. So notice I end up doing the same calculation. It's just whether I'm just considering it through a formula or kind of reasoning through it. So either way, you get that the unit cost is 8 cents per kilometer. So now we're being asked, how far can the car drive before it depreciates to 14,000? So now we're looking for N. So Vn, V0, N, and D. So now I know I want it to get to 14,000. It starts at 20,000, so I'm going to lose $6,000. N is what we're looking for, and D is 0.08. Again, measuring in kilometers this time, not per 1,000 kilometers. So plugging in all those values, 14,000 is equal to 20,000 minus ND, so N times 0.08, subtracting over, or, so at this point you can just go solve on the CAS. So solve 14,000 is equal to 20,000 minus N times 0.08. Solving that for N, I get that it's 75,000 kilometers. If I subtract, I will get the same thing. Please do put your units all the time. So there's a big difference between cents per kilometer and kilometers, so it is important to show your units. So here I figure out that it can drive 75,000 kilometers before it gets, or when it gets to $14,000. So this one is kind of the more relatable one. You can really see what's happening, that each time you use it, it goes down a little bit, and working to solve problems using that.